Much for joining us. Also wish everyone happy Ugadi and Gudi Pauda. So hope all of us will have a great year ahead. Thank you once again, and ma'am, thank you very much for joining us even in this holiday. And at this time, we are really glad to have you as a speaker. So we have with us today Professor Hema Datte. She's a professor in IT and Industrial Engineering at National Institute of Industrial Engineering. She's currently the Dean of Student Affairs with a demonstrated history of working in the higher education industry. She has completed her PhD focused in artificial intelligence from National Institute of Industrial Engineering. She has multiple collaborative projects and fellowships. She's a well-known expert in this field. We are really lucky to have you, ma'am, as an expert speaker, and our participants are eager to hear from you. Thank you once again, ma'am. On behalf of IIIT Sri City and the organizing committee, I welcome you to the session. We thank you once again for being with us today. Over to you, ma'am. Thank you.
Yeah. 1 minute.
Sure.
Hello. I hope I'm audible to everyone.
Yes, ma'am. You're audible, ma'am.
Yeah. And I'm visible also.
Yes.
First of all, thank you so much for giving me the opportunity and for my brief description also. Very beautifully described. Thank you so much for that. So today, without further ado, I will start with the session. And today I'll be describing about data analytics and what are the industrial applications and what are the different techniques that we are going to use it. Okay, so I'll start with the presentation. I hope the PPT is visible. Hello?
Yes, ma'am. Visible, ma'am. Yes, ma'am.
Yeah. So actually, deliberately, I have given the title as a business analytics because data analytics cannot be without business analytics. So I just want to mention about how the data analytics can be going hand in hand and how we are actually going to leverage on this data analytics in the today's context, considering the data science and machine learning and all this latest techniques, considering the digital transformation. So whatever is the technology, we have to perform business analytics, and for the business analytics, data analytics is mandatory. So you're already aware of that we get data from the multiple sources, and nowadays, in fact, we are calling it as a data lake. So the sometimes earlier it was a very easy to manage the data. The data was within the organization or across the organizations. Like we can have the cloud-based ERPs, and we were sharing the data within the organization. But now the concept is we are not into the only the databases and ERP systems. We are into the era of data lake. So what do you mean by data lake? First of all, the data comes from the various sources, might be some industry 4.0 devices, like say, or it can be the RFID, some transducers, or any IoT based devices, or it can be satellite communication, it can be camera, it can be audio inputs and all. So multiple types of data actually gets merged, and it also gets integrated to the internal data of the organization, which comes from the ERP, from databases, or from any other applications in whatever the format, digital format, visual format, graphics formats, or image formats, whatever format. So all the data gets integrated, and then the data cubes are formed, and based on the application, the cubes are actually getting popped up and the application gets performed. So this is this is nowadays it is more challenging because most of the data is actually in the form of the multimedia format, And that's why, of course, it gives the advantage that it gives a lot of business insights to us. But that's why the traditional techniques which we were using, like say maybe the query or just simply data mining and all, they are not going to help us. So we want to learn some, adopt new techniques for the data analytics. So what are these techniques? So whenever we get all the data, different type of data we get it, different tools and techniques are applied to get the business insights. So, and of course, as I told you, that the data we get it in a different format. So naturally, we get sometimes good data, sometimes garbage, sometimes some messy data, and it's very essential to understand what is the required data for my business, and which will be which will be defining the insights of my business. So it's very essential to understand what application we are going to perform, what is our objective, and for that purpose what data is required. So in short, we can just define the boundaries of the data. We can understand what type of data is required, in what format is required, from which system it is going to come and on. And once we are clear about it, then we can reduce this noise, whether noise is the unwanted data or out of boundary data or out of context data. So all these data can be eliminated, and we can get means what are the relevant data, and visual is helping us for the business insights. So analytics is actually, the data analytics is what the analytics is the use of data, information technology, statistical analytics, quantitative methods, mathematical or computer based models, and the all different types of models, the data science models, and they all help to improve the insights about the business operations. And based on this, what happens? So the based on this, the decision making also gets improvised. Say for example, some important I can just mention that some of the important businesses, what we can think of is, okay, these are the important business analytics, like say for example, profitability of the business, or revenue generation in the business, or shareholders returns. So when I'm saying that the profitability of the business, it is also possible that the profit I get out of the sales, so I can just focus on the sales data, but that itself will not be sufficient. So nowadays profitability is not just the sales data. We also have to see that at what process, right from the, say for in a manufacturing, from right from the raw material to the finished good, at different processes, at different means events, or different machines, or different like say activities, wherever it is possible, how we are going to optimize, how we are going to do the cost optimization, how we are going to reduce the inventory, or inventory optimization, time optimization, how we are going to maximize the efficiency. So when we do all these things, we can say that it is adding to the profit. Okay, so saying it is very easy, but when we want to incorporate all these things, if I don't have data, I will never be able to say that where I have optimized inventory or I have not optimized inventory. And this is just a simple example I'm telling you. Like say earlier, the context was profitability means sales. By sales, you are getting the profits. But nowadays, no. Profitability will not only will be hidden into the sales. It is the throughout end-to-end process. And that's how, if we don't do the data analysis properly, if we don't have the benchmarking data, or if we don't have the KPIs in our organization, if we don't measure this data, if we don't compare the data, if we don't understand the trends of the data, analysis of the data, then any of these relationships which are required for the business analytics, for the decision making, is not possible. So I just gave you this, but that's why I elaborated about this profitability of the business example. Of course, the business analytics enhances the understandings of the data. And naturally, when we talk about the understanding of the data is important, that whenever we are doing analytics, that data also should be represented into the proper format. Then only it will be in an understandable format. If the data is not represented in a proper row, columns and all, then data will never be represented. Many times it happens that we call it as a OLTP data. Sometimes what happens, for doing the business analysis, whatever the data we are getting from the routine applications, that it will itself will not be sufficient. So what we'll have to do, we'll have to get extra data, other data from say other business functions, or from the same business functions, or from the relevant processes, just to uh, just to do the analysis. So that data, the data which you require for the analytics, is always a gap between the existing data and the analytical requirement. I'm again repeating it. Whenever we carry out a business analytics, we get some data from the existing sources, whatever the sources, but if you do any business analysis, only the existing sources data will not be sufficient. So what we'll have to do? We'll also have to capture additional data, and capturing the additional data, we call it as a OLAP, online analytical processing. So through OLAP, through OLTP, we try to capture the data, additional data which is required for the analytical requirement. And then this data gets clubbed together with our existing data, and then it is getting presented in a different format. It is converted into the understandable data, and then we do the analysis. So always we have to remember that whenever you are doing data analytics, only existing data will not be sufficient. You should always have the business analytics in mind, and to do this analysis, whatever data is required, we have to capture. So how to capture the data, how to present the data, where it should be stored, at what time. Okay, the time also is very important factor, because sometimes you are doing some analysis, but if it is not within that time frame, then the data may be obsolete. So it's very essential that what time or what event, I'm calling it as an event. So the data is actually event based. Okay, so event based means, I'm just giving you the example. Suppose I'm studying the impact of my discounting. I just have launched something. Okay, or I'm just saying that cross sale. So on say one toothpaste, on one toothpaste brush is sold, say for example. So suppose if this is a cross sale is carried out, and I want to understand that whether that has it impacted, whether my sales have increased because of this particular strategy. If I want to do this, I will require the data within that stipulated frame only, right? And that frame data means when I have launched this scheme and when the scheme is ended, that data will be compared with the data when the scheme was not launched. Okay, suppose this scheme is launched now in the month of February, and I'm comparing it in the month of January. I'll be always also comparing with the previous month, and also I'll be comparing this data with the previous year's February month. Okay, so it is very essential in what context we are using, and how we are comparing, and how we are analyzing. And this whatever I have explained you, the meaning of the understanding of the data. So the data should be understandable. And if you do good analysis, then always you are remaining competitive in the business. Okay, and it helps you to create a good information reports and all, which are actually helping you for the decision making. So when we call about all these buzzwords like say business intelligence, decision science, data science, blah blah blah, all these words when we talk about, they are nothing else but they are always talking about the insights of the data. So whatever the technology you call as, ultimately you are drilling down to the insights of the data. Okay, so what are different types of data we can get? Say for example, if we are considering say business analytics. Okay, so what data we will require? Say we'll have some business case studies, we may have the case studies within our organization, or we will have some trends, okay, or impacts, or some crisis situations, or some milestones in the organization. It can be the qualitative analytical data, whatever that we are capturing. It can be the preliminary reports data. It can be some visual reporting data, some through the instruments, some through cameras, through dashboards. All these different types of data are coming, and and on the basis of that, we also for the decision making, we also create a dashboard. So that is a dashboard is a beautiful outcome for the in any business for that matter, whether it is a manufacturing firm or it is a service organization. Dashboards are also helping the decision makers to a great extent, and that they will be acting as a front end, but at the back end all the data gets populated, get analyzed, and get processed into the appropriate format and to the relevant decision makers. And it is actually giving all those analytical results in a beautifully report form with all the correlation with the different business functions and all. So this is just I just wanted to mention about like what is the power of the data. Now, when we do the data analytics, we may just come across with a different sort of data sources. So one can be the preliminary data reports. The reports might be in a soft form, might be in a hard copy form, might be in a visual form. Like say some of the policies might be documented in your strategic, like where as a strategic reports and all, or your data. Sometimes some instructions, some verbal communication, some understanding, some knowledge. So I'm saying that the data can be in a tacit format, or it can be in a explicit format. When I'm talking about the explicit format, the data is actually recorded in a digital format, in the sense like it is available into some digital in the digital format, either in a recorded format in ERP or in databases, or in some image, or or some data analytics applications and all. So it is available in certain format, which is in a recorded format. Is it available in a digital format? Then I'm calling that data as an explicit format. But sometimes the data is also hidden in a tacit format, which is the knowledge within the organization, the knowledge or the normally the culture of the organization, or the way the leadership is actually taking it forward, or somebody who are having the field expertise, they are managing the entire business, might be the crisis, might be the decision making, or might be the routine applications, the routine operations. So they are using their own business knowledge for performing this. So such type of data can be tacit data, and all this explicit and tacit data can be captured and can be converted into the preliminary data reports. Okay, so we don't have to just focus on to the data which is available in a digital format. We have to just go out of way to capture the data, and we also have to see that which data is actually used very frequently in my organization, but it is not recorded. And it's very mandatory for you to find out all this data, what is the tacit data, what is the explicit data in the organization, capture all this, convert it into the appropriate format, convert it into the data report formats. Okay, next. Actually, sometimes what happens, some of the reports are actually into the visuals. Normally you can see that the stock markets, okay, sometimes the graphic representation is more clarifying or more elaborative or more explanatory than the text or than the report. So such type of visual data also we have. Okay, so typically, is in our organization, say we are having a pie chart, or we are having a bar graph. Okay, or we are having a trend analysis, or different types of graphs, or we are having some waveforms. Okay, all these are actually in a visual formats, and these reports are also very, very important. And when we are also creating the dashboard in your organization, might be some dashboards are already created, or you are into the verge of creating more dashboard. So it is very essential that we are creating the dashboard. Okay, and also the sales forecasting data, I'm just giving you one function here, but sales forecasting, it can be the manufacturing planning, it can be the new product launch, or it can be a service industry, a customer satisfaction, or the bundle services. Okay, how we are going to give the multiple services bundled in a one as a one service, or enhancement of the services, value addition of the services, whether it is a manufacturing or a service industry. You can just, for example, here sales forecasting application is considered, but whatever is your service industry, manufacturing industry, or whatever, based on that we can consider the applications. So I'm just, in short, I'm saying that it's a application related data, whatever the business function you're performing, or whatever business application you're performing. So the data related to that also is very, very important. Now, next is actually just, I'm continuing with the sales forecasting example so that you will understand it. So I just, we are capturing this data for doing the sales forecasting. We want this preliminary report, and then the sales forecasting data analysis will be done. Okay. Now, what happens? You are not stopping at this moment itself. When you are doing this data analytics, suppose you have decided the application that you want to do the data analytics for the sales forecasting. You have captured this data. I'm just continuing the sales forecasting example. So what do you mean by sales forecasting here? Let me elaborate to some extent. Like, say a product, say for it's a financial product, an insurance company product, a medical insurance company's product is considered here. So what will be which products are preferred by the customer? What is the profile, demographic information of the customer, like say which genders, which age, which income group, whether it is a corporate customer or an individual customer, right? Or in which region. So I'm just considering the different parameters in the sense like customer demographics, okay, customer profile, or say time frame, okay, in which time frame, which region, okay, which product is becoming popular to which customers, right? And also we can say that in a which country or in what context. Are you getting it? So if I really want to do the data analysis, I'll have to really literally do the postmortem, and each of these I'm saying that in which time frame. So I can get the time frame postmortem, in the sense I can just drill down time frame further. So yearly performance, okay, yearly performance, or daily performance, weekly performance, monthly performance, quarterly performance. If I'm saying the customer, then customer age, customer income, customer gender, I'll have different combination. A female with say 50 years age and certain income, or a female with 25 years age and in certain income. Are you getting? Or a male with 50 years age and certain income. So I can have the different combinations of the data. Okay. So whatever the parameters, whatever the fields I'm going to consider, every field will have the attributes, and I have to drill down to the level of the attributes, to the level of the granularity. I'm using one word as a granularity, means I'm going to the depth of the data, so that the data is going to give me the all the insights of the business. Suppose if I'm considering the customer and I have just eliminated some data. Suppose I'm just giving some another example. Say recency, frequency, and monetary gain. Suppose if I'm saying that which customer is beneficial to me. So probably you may say that, okay, the customer who has given me maximum profit now this month will be beneficial. Okay, he is my good customer, but I'll say no, he's not your good customer. Because if we really want to do the business analysis, if we really want to have the business insights, so this month whatever he has given me profit will be the this month's best customer. But if I want a good customer, or I want to create a database of the good customer, only on the basis of the 1 month data I can't decide. So there, if I want to see which are the, if I want to do the customer ranking, I want to understand a good customer, then I have to see all the three parameters parallelly: recency, frequency, and monetary gain. Recency will be how long the customer is with me. Frequency is how many times is giving me the business, how many times, I'm giving me opportunity for the sales, okay, or I'm making taking profit out of it. And monetary gains means how much of profit I have made out of it. So just on basis of one parameter, I can't take any business decision. Then it will not be a good business analysis. Are you getting what I'm saying? So if I really want to understand which is a good customer, I want to consider all the three parameters together: recency, frequency, and monetary gain. And all these three parameters together will decide which is a good customer, bad customer. So here, data, that is the beauty of the data analytics also. We have to define the context. We have to understand which cluster of the data is required, okay, or which parameters should be clubbed together, or which attributes should be clubbed together to make the analysis meaningful. Okay, and that talks about the entire data analytics. So now if we really want to perform data analytics, so we are here, this is the, I'm just, whatever the portion I'm showing is the data analytics portion. The application considered here is a sales forecasting. But to do this application, I have to do something pre-work and some post-work. So if I do this data analytics without the, this is what I have shown, it's the blue part, and what are the prerequisite, then my data analytics will not have any meaning. So what I have to do is I have to capture this data, preliminary data reports, visual reports, dashboards, and all. I have to just capture it. I am doing the sales forecasting now for this application, and then I have to predict also a future. So using the data science, I can just do some prediction analysis also. So then I will say that yes, I'm doing a good data analytics, and that's why data analytics, there is a difference between the data analytics and data mining. When you just existing data, you apply analytical technique, I'll call it is purely mining. I have just mined the data, I have come out of the result, whether these customers are good, or how many customers have given me business for last 1 year, or my which products have given me maximum profit, or my which products have not done good, or my which services, which services are actually popular amongst the customer, or how many customers are availing my more than 2 3 services, something like that I can find out. So that will be merely the data mining. But if I do the data analytics, I'm just also not ending at this mining stage. I may do mining at this stage, but when I do data analytics, it is also be supported by the futuristic need. So predictive, and that's why we come out with the prescriptive analytics, descriptive analytics, okay, then the prediction analytics, sentiment analytics. So all these different types of analytics are the outcomes of this data analytics. So please try to understand the difference between the data mining and data analytics. Mining will be just applying the analytical techniques and will be giving the results. But when I talk about the analytics, data analytics, it has got a specific business context. Okay, it will be always correlated with the business analytics. Whereas the data mining has nothing to do with the business analysis. Given the data, you are applying the technique. But when I talk about the data analytics always has hand in hand, it will be going along with the business analytics. It will be always considering the futuristic need. It will be always capturing the past report. And this is the crux of the data analytics. And this is the differences between the data mining and data analytics. Okay. So now when we are doing all this analytics, okay, so what all techniques, analytical techniques we can use? Even we can go to the analyticals using the speech recognition, image recognition, These techniques are also used for the analytical purpose. We can also use machine learning algorithms. Okay, we can use the data science algorithms. We can use, say for example, I want to predict the loyal customer. So just now I mentioned that who will be my loyal customer. Can I say that the customer who has made this month has given a huge profit to me is a loyal? No. Can I say that the customer who has given me one time huge order is a loyal for me? No. So whom I will declare it as a loyal customer? The customer who is steady with me. So whose recency means length of service, frequency means number of time he is giving the business opportunities, and monetary gains means he is giving a profit. When he is striking balance of all these RFM, three parameters together, then I will call that customer as a loyal customer. Are you getting it? So this is my business analysis I want to do. Say for example, what I'm looking for, I'm trying to understand what is the loyalty of the customer, and I'm going to predict the loyalty. So I'll have to define what do I mean by loyal customers, and then I will capture all the reports in this context, and then I'm going to do all this analysis. Okay. So this is the way. So you just can't do just data mining. Just applying data analytical techniques is not data analytics. Next is actually, we can see that yes. So as I already mentioned, that data analytics is also related to the business intelligence. So now what do you mean by business intelligence? So here you see that business intelligence is actually the creating the dashboards or creating the visual reports is also a part of business intelligence. So real-time decision making, real-time intelligent decision making can be done with a visual reporting, with a dashboard reporting and all. And that's why the data analytics job is also to support this business intelligence. So are you understanding a multiple fold applications of the data analytics? It has to support the business intelligence, or the intelligence, real-time decision making. It has to just complete the futuristic need. It has to predict. It should have the capability to the predict, to prescribe, to describe, okay, to do understand the sentiments of the customer, and all these things, the futuristic analytics, that also it has to do. So data analytics has to do a multifold applications. Fine. And that's why we'll see that what are the different types of analytics we have to do as a part of data analytics. So now you have understood that data analytics is not just applying technique on the data and then that's it. We have to do much more. So what are the different types of analytics we have to apply is descriptive analytics. So descriptive analytics will be just trying to find out from the data. It will be the huge data. From the data, it is going to find out what happened. Okay. So what happened will be the talking about the descriptive analytics. Predictive analytics is telling that what might happen. Okay. So we are getting all the reports and existing data and all, and that we are trying to analyze, and we are trying to understand what has happened, right? In a predictive analytics, we are focusing on to the futuristic need, like what might happen. And the third type of analytics is the prescriptive analytics. There we are just trying to do as to what should we do. So it's like a prescription of a doctor, what should be done and what should not be done and all. Okay. So what are the, say for example, what are the risks associated in my business? How I can mitigate that risk? Okay. How I can enhance my market? How I can increase my customer base? How I can improve my productivity? How I can launch my new products, in which country I should launch. Okay, so all this, or in which location I should launch, at what period I should launch, how I can do my market basket analysis. Okay, which strategies I can plan. So all this will be the prescriptive analytics also will be done, which are going to do the value addition to the business. Okay, next. So I'm just talking about the descriptive analytics. When we talk about the descriptive analytics, what it is talking about is that it encompasses the set of techniques that describes what has happened. When I'm telling past, please understand past means not the historical data. Past has got some specific meaning. Okay, let me explain you the meaning of the past. Okay, say for example, a customer has placed the order. So I'm considering that customer has placed the order. This is my business process. So placing order, what is the starting point and what is the ending point for the placing order? Customer has send the requirement in whatever the format, through the telephonic, through the your standard, standard customer purchase order format, or through the email, or through the phone, or whatever the format. Customer has specified the requirement what he wants from you, that will be the customer purchase order requirement. Now, how long this customer purchase order will be lying there? What is the time span of the customer order? So customer order will be lying there only till the customer order is completed. It is possible that if you have the inventory, today itself will wind up and today itself will get the payment. But if you don't have inventory, probably you can hold the customer, you can keep the order on the hold, and whenever you are getting the sufficient inventory, that time you are going to process the order. So it is possible that the order is launched today, the logging of the order has happened today, but you have completed the order, say, after 5 days. So the customer order processing got over after 5 days. Okay. Whereas in some other customer, the customer order processing got over in 10 minutes also. So are you understanding? So past data means I'm talking this as a process. The process is getting completed. Okay. The business process is getting completed. Now, for one customer, it got completed in 5 days. For other customer, it got completed in 10 minutes. Same business process. But because in one inventory was available, that's why immediately got order got processed and the payment also is done. And in some other customer, suppose the customer order is actually processed, is not processed because inventory was not there. Now I'm just adding something to it. Suppose we are getting the B2B customer and we are giving 3 months credit to the customer. So it is possible that you have processed the order, but means the customer order processing part is done, but customer payment is not received. So I'm splitting up customer purchase order into the two parts. One will be the processing the order and delivering the goods and receiving payments. So this customer purchase order will be divided into two parts. Receiving payments is one part and delivering the goods is another part. So it is possible that the customer purchase order is not completed because we have given 3 months credit to him, to the customer, and the customer may pay within the 3 months span. And when this order will be completed, when this process will be completed, when he will make the payment, that time I can say that for this customer, this order is completed. Are you getting it? So the past means the moment it is over, the moment the particular process is over, it becomes a past. It's not a historical data. Please try to understand the context of past. So whenever the data is, whenever any business process, any business activity, okay, is any business event is completed, then we call that the data, it become a past. So from starting to end, when the process is completed, we will call it as a past. So past is not a historical data or old data. Past means just 5 minutes back I have processed the order, finished it, means it has become a past for me. Okay. So yeah, what has happened in the past? So I have just elaborated about this. So sometimes you may process the queries, you may generate the reports, then some statistical analysis can be done, some visualization is done, say some data mining techniques are used, or some what if analysis is actually done. When such type of all this analysis will be done, we are calling it as a descriptive analytics. Okay. So we are trying to describe the data in the form of queries, in the form of reports, in the form of the statistical or quantitative techniques, in the form of the visualization or data mining technique or spreadsheet models and all. And when you just do this, when you try to describe the data in a different format, it will become a part of the descriptive analytics. And this descriptive analytics can be, can be in a different format, as I already mentioned. So it can be in a table, charts, maps, summary statistics, or updated new data. New data, you can populate some new data also, and it helps the manager for decision making. Okay, for managing the company's performance. Then it also helps the people to summarize the day-to-day information. Say, for example, sales by region, sales by current inventory levels, or say, like the company-wide matrix. So what is the sales performance, performance of the group, performance of the product, performance of the region. So such type of information also we can capture, right? Then frontline managers may view the dashboard. Suppose if the dashboard is created, they can view in what format. So how much of staffing level is allocated, mean which staff should be allocated where, what should be the inventory level, okay, or what will be the sales forecast. So all such type of things we can capture through the dashboards, right? And that's why the dashboard also is very, very important for the data analytics. Now, yeah. What happens? We can get this past data, and yeah, we can get we can get this descriptive analytics. So this is the basic data, and then we can get it in the form of the dashboards and all. So now we can see the predictive analytics. In a predictive analytics, what we are getting is, it predictive analytics consists of different models which are constructed from the past data. So in a descriptive analytics, we are trying to capture the existing data from the dashboard, from the reports, from the statistics, from the visual techniques and all. And in a predictive analytics, what we are going to do, we are trying to use the techniques which will be modeling or constructing the past data to predict the future. So we are using the past data to predict the future. And this data would be actually helping us to give the insights of the business and for the decision making, and lot of the risk mitigation, the opportunities, the different business opportunities, or we can say that the say we can profitabilities, or the sometimes suppose your understanding your business is doing well or not doing well, or product is doing well or not doing well. So all the crucial decision makings can happen based on the predictive analytics. Okay. And this survey data and past purchase data, the behavior, all this, the what are the market shares about the new product, and all this data will be helping us to do the predictive analytics. And for predictive analytics, we can use the different techniques like say linear regression, then time series analysis, the simulation. So all these techniques can be used for carrying out the predictions. And this data mining techniques are actually, are creating the different patterns. They are giving the relationships among the data elements. Okay, if we are having a huge database and we are carrying out the predictive analytics, it will generate the patterns, and on the basis of the pattern, the forecasting can be done, the predictions can be done. So the same pattern will be followed. Say suppose if I'm saying this is the once a peculiar pattern is followed, the we can just I'll just show you some of the examples also. The pattern normally gets repeated, or there will be some variation into the pattern. So on a time frame basis, how much of variation is happening, and then we can just do the prediction model, we can do the forecasting. Okay. Even the simulation is also a very powerful technique used here. And we can also use the probability or statistical constructs, or we can also use the simulation model for the understanding the impact of the uncertainty in decision making. Then the next comes the prescriptive analytics. So once we do the descriptive analytics, we do the predictive analytics, and then we can do the prescriptive analytics. Now, prescriptive analytics is actually like, it is just asking you to what to be done. So it indicates the best course of action to take. So what can be done in this current situation. Okay. So based on the descriptive and predictive analytics, the prescriptive analytics is actually means lined up or the geared up with these two analytics, and it is also having the lot of optimization models. And these models, they give the best decisions for the decision making, subject to like whatever the constraint situation. So for some of the examples, that's why for the examples, some of the examples are highlighted here so that you will get a better insight. So for example, portfolio management. When we are doing a portfolio management, what happens in finance? Normally, the historical investment return data is used to determine the mix of investment, which gives the highest yields and all, or expected returns. And of course, when we do it, we are also controlling or limiting the exposure to the risk. So it is say this is just one of the examples. So prescriptive analytics is when you are doing the portfolio models, when we have a portfolio analysis for the financial investment models and all, you are also taking into the care, you are also your models are also exposed taking the into consideration the exposure of the risk, and the risk gets mitigated, the risk gets controlled through these models. Okay. Then say supply network design model. Now if we want to in the field of operation, suppose if we want to just design the models for the supply chain management. Say for example, provide the cost minimizing plant, okay, or distribution center location, subject to meeting the customer service requirement. Now suppose if our customers are B2B, okay, it is possible that all the customers will not be near to the plant. So how you will do it? Okay, if you will take a call. Suppose you say your organization is a very big and you are having say 10-15 plants, and now you want to take a call that where the distribution center should be. So if I want to take a decision about where the distribution center should be, I'll have to do lot of analysis. What is the analysis? Can you guess what sort of analysis? Just for the decision where the distribution center location should be. So for that purpose, I'll just get all the sales data. Say last 4-5 years sales data I will just capture. I'll try to understand how the sales are increasing, whether they are increasing, whether they're stable, if they are increasing, in which region they are increasing, how much they are increasing, right? When they are increasing, what are the peak periods of the sales? From the sales data, I'll study all these things. So in which region, in what time, at what time frame the sales are, what is the behavior of the sales or the performance of the sales. So this is one observation I'll do. Another thing is I will also find out that in which regions more customers are there. Like you will find that in any business there will be sometimes some regions are very customer dense regions, some regions the customers are not many, but it is possible that one a big bulk customer is there where a huge order goes, but not many customers. So you will find a different patterns, like sometimes you'll find a cluster of customers who are actually the medium range, but the area is so dense that lot many your customers are situated in that, and individual customer is not giving you the big business, but multiple customers and frequency of the orders is giving you the big business in that area. In some area we'll find out that okay, the customers are actually the big customers, say one or two big customers are there and they are giving me the huge business, okay. And some places will find that there are no customers, very hardly any customer is there. So if I want to take a call where the distribution center should be, I'll have to understand across the geographies how the sales is happening, where the customers are located, where my plants are located, okay. Only that data is not sufficient. So what further I'll have to do? If I have a distribution center in any location, also I'll have to see that how much of logistic cost I'll have to incur. So from that distribution center to the customer point, okay, how much will be the logistic cost I'll have to incur? What should be the capacity of the vehicle? So suppose if the per day, suppose 10 tons you are carrying. So how many trucks I will require? How many trips of the trucks I'll have to make? How much of logistic cost I'll incur? So when I'm doing this customer analysis of the sales, I'm not only doing that how many quantities are sold, but also have to understand that product analysis. So what is the product analysis? Is that yes, how much of product, how many tons of product is going, okay, what time it is going, in the beginning of the month or in the end of the week or beginning of the week or a specific day or specific month, what is the pattern. So if I understand that how much of volume I have to just transport every time to the customers where I have to just meet their requirement, then it will be easier for me to understand the truck capacities or my logistics requirement or my logistic cost or my logistic time. So please understand that here we are just thinking of distribution center is only one data. I have to just take a decision of the distribution center. But while doing the decision of distribution center, I have categorized my data into different formats. So some parameters customer related, some parameters geography related, some parameters sales related, some parameters how much of product I'm selling it, the weight of the product, the volume of the product, the frequency of the product. So are you getting it? So you have to classify the data. It's very, very important that when you do the data analytics, what context, what business application you are using, and accordingly the classification of the data is very, very important. And then you capture the data. So I hope you understood that if I just want to see that where the distribution center location should be, I have to completely understand the customer service requirements, means to which customer, when, how much of tons or how much of kilos or how much of quantity I'm just selling it, okay, what logistic costs I'm bearing and all. And then considering all these things, then the distribution center locations can be planned in such a way that my logistic cost is increased. So the distribution centers can be in a very optimized location which can be nearer to the plant or the nearer to the customer location. Okay, it cannot be far away from customer location also and far away from the plant. So I had to optimize the cost. It will be the best if it is the close to the customer location also and close to the plant. But we are not fortunate that always we'll get this good choice. So it is sometimes it is possible that it can be either close to the customer or close to the plant. So when we have to, when it can be close to the customer density zones, or when it can be close to the plant, that we have to understand, right? And on what basis we'll understand the data? What data? In which area, how many customers are there, number of customers, frequency of the orders, how many tons. And then if I find that yes, bigger volume is going very frequently to this location, then it is possible that the distribution center, I'll fix it at that location. So please understand, when you do any data analysis, it's very important that what is your business function, what data you want to capture. It's very, very essential to classify the data, understand the context of the data, classify it properly, and then go to the depth of the data and then capture. Without just this thought process, without classification, without context, if just try to capture the data just superficially, then always we are actually going to enter into the garbage in, garbage out. Now, another model I can just mention about the price markdown model. Now, in this can be used for the retailing. So, it is using again the historical data to yield revenue maximization, discount labels, and timing of the discount offers. And when goods have not sold as per plan. So, normally when the discount will happen when the sales are not happening as per the plan. So, you try to push out the goods into the market, and that's why you will slightly offer the discount, and then you will try to sell out. So that also we have to plan it. So if we are discounting, how much price should be? So the price should not be so that we are making losses, because since the sale is not happening, that's why we are trying to give the discount and we are trying to attract customer. It is possible that my sales volume may increase because of the discount, but at the same time I have to see that the losses cannot be made. So here, if I have to classify the data, what all I'll have to do is I'll have to see that which product, okay, how much of sales are affected, how much of losses I may, it may happen that my sales are not happening, or I'll have to how much of discount I can. So I'll have to do that break even. How much of discount I'm just is going to give me a better better revenue generation. So all these calculations can be done. So here the financial data about what should be the pricing strategy, okay, how much of the quantity is expected sales and what will be the pricing strategy, and then what should be the discounted price. So I have to classify the data in this fashion. So please remember that you always have to classify the data, and then then you have to just go ahead with it. So here we can see that the database informations and on this analysis, all this will be coming. Then we can also see the examples of using the data, say annual reports, accounting audits, financials, profitability analysis, economic trend, marketing research. All this data will be there. Then metrics, measures, discrete, continuous data. So discrete data. So this is the data analytics is not, the type of data and all is, it's always from data mining. We have already picked up. These are the typical classes. This is not defined now. Data analytics is new, but what type of data, what type of measure, discrete data, continuous data, this is going for years together. So that's why I'm just rushing through the classification. You might be already aware of it. Is the quantifying, we are just we are using some data for the performance, then measurement of the metrics data, then some discrete event related, okay, data which are time based data, okay, or the number of proportions on the time deliverables, then the continuous data, say delivery time, package weight, okay, pricing data, such type of data. So you can see here, you can just capture this such type of data, and this is all the traditional way of capturing the data. So I'm not wasting much time in it. Okay. So now, if we really want to do the categorize data, data intervals and ratio data, okay, all this data you already know. This is years together. This practices are going on. So I'm not wasting time in this. Now, when we do the business analytics, we can do the financial analytics, human analytics, market analytics, healthcare analytics, supply chain analytics, okay, or the government or non-profit analysis, sports analytics, web analytics. So different types of analytics can be done in the practice. And if we do this analytics, what the spectrum of the business we consider through the data analytics. See, you can see that we are doing the predictive, we are doing the prescriptive analytics, predictive analytics, and descriptive analytics. So if you see the competitive advantages, some of the olden techniques are also using, say, standard reporting, data query, data visualization, then statistical descriptions, okay, These all will be part of the descriptive analytics. Okay, this all will be part of the descriptive analytics. Now, sometimes you will find that this is a merging happen. So some of the techniques of data mining can be used for the descriptive also and can be used for the predicting also. So data mining can be common for both, can be predictive also and for the descriptive also. Say for example, I'm telling you that I want to understand whether I can, if suppose if I want to launch a product, a new product into the international market. So I want to understand that yes, which country I should go in. Now, if I want to take this crucial decision, I may have some GDP data, some economic index of the data, the trend, like say the awareness of the data, the lifestyle of the country, and everything. Also, I'll also see that what are the energy requirements, what are the infrastructure costs, whether the country is ethical, whether they are going to what way they are going to have a profit margin, how much liberty I'll get, how much freedom flexibility I'll get, or they will just kill my profit share. So all this aspect I'll have to study, and probably I may study with for the different countries. I'll see that what are this impact is happening of this data, and then I will take a call if I really want to just the choose a new country for my business where I can launch my product. For that, I'll have to really do the comparative analytics of all these different countries, and then I will take a call which country will be better for me. So I can do the data mining, I can do the forecasting, and then I will do the prediction. Okay, this country will be the right. So sometimes what happens is the descriptive and predictive analytics, sometimes we will find that slightly overlap will be there, and there will be thin overlap will be always there between the descriptive and predictive. And then we are having a multiple predictive models. I'll just show you what are the different models, that also I'll mention. Then next is actually the prescriptive. In a prescriptive, what happens? So you have done the description, you have captured the data, you have predicted what can be happening and all. Now this will happen, and if it is, say, suppose you are going to increase the sales. So what way it can be be increasing the sales? So we are doing optimization, decision analysis, simulation, and all. And on the basis of that, suppose if I'm entering that, okay, if I'm entering into the Germany, and I'm just launching the high-tech product. So in a Germany, high-tech product will be a big challenge because already Germany is known for the high-tech product. So how many challenges I'll have? So I may simulate it. I will just do the pricing strategy. I'll do it. But suppose if I want to launch the product in say Taiwan and all, which is a high-tech product, probably that much of risk will not be there because the country's technological awareness of that will not be there. So there my simulation model will be focusing on a different parameter. But if a high-tech product, if I launch into the Germany, then I will more focus on to the technology oriented, the reliability of the product, the quality of the product. So there the simulation problem will be focusing on that data more, because the context is I'm launching my technical product, I'm launching my any the technology savvy product into the country which is already known for their quality and reliability, Germany, Japan. But if the same product, if I have to launch in Taiwan, probably those aspects I may not keep it as a higher priority, but I may say cost or aesthetic value, or the all these parameters I will give a different, I will give more importance to it, and my simulation model there will be giving a weightage of the reliability and lesser weightage as compared to the pricing and the aesthetic value as a more weightage. So are you understanding that when we do the simulation, the context is also very important. In what context, what business, what application, what data analytics, the context is very, very important. And in this context, that's why the same product, we are entering into the different countries, the simulation parameters weightage might be different. So I can design a simulation model which will be picking up the parameter values based on the country. So I can just use my AI/ML algorithm, I can use the intelligent algorithm. So the moment whatever the country I choose, it will automatically pick up the values, it will automatically prioritize, and my optimization model will run, and my decision analysis will do, and it will prescribe me what to do. Okay, so these are the some of the things which are very much related to the data. Now, like different types of analysis, like customer analysis, financial analytics, and then supply chain analytics, I already mentioned. Okay. Then when we are doing a predictive analytics or the prescriptive analytics, or they are also referred as the advanced analytics. Sometimes people, as I told you, that predictive prescriptive analytics will not be really mentioned separately, but we call it as advanced analytics. Okay, so it is possible that we are just coining the term as the advanced analytics, right? So when we do all these things, there are some specific models for the advanced analytics. And for financial analytics, we are using the forecasting, forecast future financial performance, or the risk and investment and portfolio management, or construct a financial instruments derivatives models, or optimum portfolio investment models. Okay, such type of different budget planning models are there. Even when we are simulating the risk, so there are some different models are there. For HR, we are having say MISC, or set skill sets related model, highest quality or talent model, or hiring quality model, or the achieving targets or diversity goals related model. So as I told you, based on the different context, we are having the different models also. And we have to just choose which model is more appropriate, considering whatever the data is available in my organization. Suppose if the data is not there, then we will have to capture the data, feed the data to the model, and then only we'll be able to perform the data analytics. Say for example, for the marketing analytics, we can just understand that yes, able to understand what are the fastest growing areas. Okay, which product, which area, which customers, okay, what strategies. So we'll have to understand the complete analytics for that. Then for consumer behavior, you can understand the completely, what are the whether the social media impact is more, or the marketing analytics interest is more. Okay, and we have to understand the customer behavior, we have to understand the sentiment analysis. Okay, then better advertising, better pricing, then forecasting, demand forecasting, the product line management, customer satisfaction, loyalty, all different types of analysis we'll have to do. So it's very, very important to understand that yes, we are doing all the different types of analysis. And similarly, in a healthcare, we are doing say patient, staff, facilities analysis, patient flow analysis, inventory control analysis. So there are these different types of analytics we actually carry. In supply chain, say for example, say FedEx like company, they are trying to understand what is the efficiency. Okay, how the scheduling, scheduling, staffing, vehicle, different logistic companies that tie up with the different logistic companies. So please, I'm just giving you the different examples so that you will get the insights to understand the different data. And these are the different practices which we'll have to follow for any of this analysis. Now, if we want to really do the business analytics using the data analytics, it is very, very essential for us to understand and recognize the problems. We have to define our problems properly. We have to structure the problems. Okay, recognize the problem, define the problem. We have to structure the problem properly, analyze the problem, convert into the different classification, and then try capturing the data. And this will help you in getting the better results, and then you will get a better solutions also. So I think it's since time up, I'm closing at this moment. If anybody is having any doubt, please, you are free to ask. I just wanted to mention about the different types of algorithms like decision support system, descriptive analytics, discrete matrix, entities, field, influence diagrams. Okay, all these things are very, very important for actually getting this data. So yeah, actually, this data analytics only 1 hour is very much less, but I wanted to cover some case studies and all. But since the basic purpose was to just have an introductory session, so I have just made my objective. If anyone is having any doubts, you can please feel free to ask. Otherwise, I'll close the session.
Thank you very much, ma'am. It was really a very intuitive session. I mean, it was very informative, very interesting. Participants, any doubts? Any doubts or any queries, please feel free to ask. Ma'am is an expert in this area, so please utilize the opportunity.
Okay. Thank you so much.
Thank you, ma'am. Thank you so much for taking time, and especially at this
Thanks.
time, it's a late evening. Thank you again, ma'am. Thank you very much.
Yeah, my pleasure. Thank you.
Thank you. So participants, thank you for attending that session. So we have one more session. So we have with us Mr. Deepak Choksi. Good evening, sir. Sir, I think you are muted.
Good evening, Professor Arun. Sorry, I was moved.
Yeah. Thank you for joining us, sir. And it's really a pleasure to have you with us today.
Thank you for
So
having me
I'll
here. My
yeah.
pleasure.
So participants, so we have Mr. Deepak Choksi. Uh, Sir is an expert in the field of GIS. He's currently the Chief Technical Officer and co-founder at Bhugol GIS Private Limited. Previously, he worked as a senior project engineer at IIT Bombay. He's having almost 25 to 30, 25 years of experience in the field of GIS. So, without wasting much time, we can directly go to the session. We are really happy to have him with us. Thank you, sir. Thank you very much for joining us once again. Over to you.
Yeah. Thank you, Professor Arun, and thank you, IIIT, for having me here. It was my pleasure, to giving this talk. And as informed, my topic for today's presentation that has been given to me was, about giving you an introduction to geospatial technology, or I'll say introduction to GIS. So my talk and the presentation will take you through, different aspects of GIS, and I've been also told that you'll be already given some kind of an exposure about utilizing the GIS tools and technologies, and how the GIS system can be used. My talk will be mainly towards giving you the concepts of GIS. There is one way by which you can use the tools of geospatial technology and come to certain results. Uh, Beyond that, if suppose like but then utilizing that tool will always require your understanding of the theory of the geospatial technology. So my talk today will take you about the concepts of GIS, and how you should understand the data and understand the GIS methodology with reference to the solution that you are looking for. So in that context, my talk will take you through. I know it's a late evening, and but then please allow me to present to you one of the very interesting topic of today's time, which is like it's a buzzword in the industry, and even with the government of India putting lot of emphasis and lot of uh, we can say uh, options in terms of utilizing this technology in different areas, right? So this is really a technology which I feel even if you are from any of the field, the technology can be utilized. And as you might have seen over the period, it's purely an interdisciplinary area. So with that context, knowing this technology will only going to benefit. And of course, even if you are from computer science background, it has lot of utilization and lot of use cases, so as with other different areas. So just allow me to make my presentation. Yeah. Hope my screen is visible to you. So
Yes,
as
sir.
I
Yes, sir. Visible. Yeah.
thank you. So, as I mentioned, the topic that I'll be covering today is about introducing GIS, which is Geographic Information System, as the name shows. Right. Now, just to give you a brief about the GIS, and I already covered that up in my initial talk. Uh, there's a lot of areas, and we can say a lot of fields in which it has grown interest, and it just says 3 decades. In fact, now we can count it as 4 to 5 decades, which has it has taken a lot of growth in terms of theory, in terms of technology, and in terms of different areas in which it can be utilized. So now, as I again mentioned, it's not limited to a particular field or particular area of the people in which GIS is useful. Just as the slide shows, the computer science, the mathematics, the civil engineers, the surveying, the economics, the agriculturalist, geography, social science, environmentalist. There are few of the areas which I can name it. In fact, we have come across people working in varied area where they have utilized GIS as a technology. Social science is one of the biggest area which nowadays they are utilizing GIS technology. Okay, and one of the very important thing which is in today's science GIS utilization, if you ask me, GIS is utilized in the form of workflow management. So no matter what area you are working with, workflow management is something which is very, very crucial in today's time. So wherever you have any particular workflow, GIS can form a very integral part in that particular area. So just to name, few of the areas where GIS can be utilized, right? It is mainly focuses on hardware, software, information processing, and that's where workflow management comes into pictures. And finally, developing different applications which covers GIS. All of us know about Google Map, right? Who was knowing the maps that easily before Google Map? So now with Google Map, which is one of the primary application and one of the easiest application what geospatial technology has given, we all are now with our mobile and in our everyday's life we are utilizing GIS in one way or the other. So that's one of the applications which you can talk with reference to GIS technology, right? So now the word which we just mentioned, information. So information processing. So GIS basically works with information processing. So as we all might be knowing, information, what is information? So information is nothing but it is derived from interpretation of the data, right? For GIS, it is more kind of a symbolic representations of a feature. So any geographic data, right? We are talking about the geography, like the word itself says GIS. It stands for Geographic Information System, right? So which has word information and which has geography. So what it says, information is derived from interpretation of the data, which are symbolic representations of the features. So now features we are talking about can be any feature. Can be if you talk with reference to geography, it can be any geographic feature which you can symbolically represent. So let's say you are talking about a bus stop. Like a bus stop is a geographical feature, or let's say we talk about a tree. A tree is a geographical feature that you can represent a tree with a symbol of a beautiful tree pointed over that, or you can put a bus stop with a symbol where a bus stop with a standing stand and a square putting over that. So which is then when you put that a system, that information which is like with the data which says that there is something on the ground, that becomes an information which is interpreted from the data, right? So of course, as we all know, the value of information depends on its timeliness, context in which it is applied, right? So if you are working for a city mapping and if you are trying to put an agricultural field, then the information has no meaning in that, right? So what's important that city scenario is you need all the city related features, right, in the urban context. So we say the value of information depends on its timeliness. So what is today was not there in 2000, and what is today will not be there in 2050, right? So we need to be specific with reference to the timeliness, right? Which time the data is being the information is being represented, right? The cost of collection, storage, manipulations, and presentations. So depending on that, the value of information lies in, and that's why we all use Google Maps so efficiently. So information is a valuable asset which can be bought and sold for a price, obviously, right? So as we all know, information, they basically fall in two categories. One is transaction processing system, and other is decision support system. So transaction processing system is all what we do our banking transaction. You buy and sell. You buy a ticket, railway ticket. You sell a say at the same time we do all these e-commerce transactions. So all these are go under transaction processing system. The other type of information system is a decision support system. So the decision support system is nothing but its main emphasis is on manipulation, analysis, and finally model the data which is available to that, which helps you make decisions. So you model the data, you bring out the information, and then finally make use or making a effective decision. Sorry, right? So this is very, very useful in marketing analysis, resource planning, any of the area related planning, defense, etc. So GIS basically helps you in this decision support system category. So GIS belongs to the second type, right? Now this is in brief about the definition of GIS. uh, when you open the GIS books, you will find so many different definitions of GIS, right? What I've tried to bring in here is, this particular definition of GIS is something which has been pulled out from different materials and tried to fit in here, which gives you a gist of geospatial technology in large, Okay, to give you an idea about what GIS is all about, right? So what we will do is we'll very slowly go through each and every point of the GIS topic, right? This definition, so that we'll also understand how the data and what GIS as a technology utilizes. Okay, and as you know, as I said, you are free to ask question anytime in between, or even you want to have any questions, you can please ask me, stop me, and if you feel I'm going fast, you can interrupt me and make me just answer your question. So now the definition, what is GIS? So as we said, a GIS, a geographic information system, is a tool. Now it says the word it's a tool. It is a tool in the sense whatever we learn in GIS, in the name of GIS, a geographical information system, what we learn is finally being applied in the form of a tool. When I say tool, it means a software tool. So the entire concept and theory of GIS is being used in the form of a tool. So finally, when you are saying I am using a GIS, I'm using GIS in the sense in today's time, it is nothing but we are utilizing a GIS tool, right? It's a software tool. Now, then it further says which can accept large volumes of data. I'm removing the word special right now. I said which can accept large volumes of data. Now I'm saying what a GIS is a software tool which can accept large volume of data. Now this data I'm talking about, a GIS tool can handle data, right, which is of large volume. Right, here the definition says special, but I am removing special. I am saying data which can accept large volumes of data. Now, when I say data, a GIS tool can handle two type of data. Type 1 data, which is called as a special data, right? A special data is something which we can understand as a special data is data pertaining to the space. Any data pertaining to the space, we can call it as a special data, right? I gave in the beginning an example of a bus stop. I gave an example of a tree. So what does it what it represents? There is a feature which occupies certain space on the ground, right? So that is something what we call it as a special data. Similarly, even if you say atmospheric data, we talk about oxygen, or we talk about the nitrogen. That is also nothing but that's also occupies a space. So that also we can represent as we can call it as a special data, right? Similarly, we talk about roads, buildings, right? We talk about we can say rivers, right? So all they are what? They are all nothing but a feature which are physically present on the surface of the, we can say, in the space. Even if we are representing a Mars data, so that is or something in the space, so they are also nothing but we can refer them as a special data. And all these data can be accepted by a GIS tool. So that's why it says a geographical information system is a software tool which can accept large volume of data. I just give an example of special data, right? So which can accept large volume of data. Data mainly categorized into two types: a special data, which I just explained, a data related to the space, right? And other is called as a non-spatial data. Non-spatial data is like we all commonly know it as a attribute data, right? So which is nothing but a data pertaining to the special data. So now when we are searching on Google Map, we type an address. Let's say I want to go from say Chittoor city railway station to IIIT college, right? So IIIT University. So what it will show, we are just typing a name. So that is nothing but there is a spatial data which is there in the name of the college, in the premises of the college, which has been given a name, which is nothing but a non-spatial data, which is data pertaining to the spatial data. We represent them as a non-spatial data. And anything beyond that. So now when we talk about, let's say, a Chittoor, so Chittoor as a we can say it as a Chittoor as a city. It is its population, its male female population, its literacy rate, and XYZ. So that is all nothing but data about spatial data. So it's called as a non-spatial data. So GIS, again, we'll come to the definition. GIS is a tool which is a software tool which can accept large volume of data, spatial data and non-spatial data, right? Spatial data and non-spatial. Spatial data is data related to any data related to the space, and non-spatial data is data of the data representing the information or the features information in the form of attributes, which is called as a non-spatial data. Right? Now, this data is derived from variety of sources. So now the word comes derived from variety of sources. So where does this data come from? Okay, probably in your earlier presentations on GIS. I don't know how many, you might have covered a couple of presentations on GIS. So, uh, it might have talked to you about, different set of data which is being utilized in the GIS tool, right? So where does all this data come from? Some of you already know it, right? So, but just to give you more clarity, from where all the data comes from. So it says derived from variety of sources. Now the word variety of sources, it means this data come from different sources. So now let us talk about the primary sources and the secondary sources. So what are the primary sources? What do you mean by primary sources? The data which are coming without, and which are freshly collected, right? And we are not utilizing, which is something which is an existing source. And which is a secondary sources. Secondary sources means which we are utilizing the available source of data, and we are generating a secondary source. So that is called as a secondary source of data, right? So now this data which are derived from variety of sources, the primary source of data deriving of spatial and non-spatial data is, for spatial data we all know about lidar, right? We all know about drone. Now today's time drone is very, very common. We all know about a person, you might, everybody of must one might have seen, person carrying the unit like a structure in the hand and standing on the road where somebody is taking reading, so which is called as a total station. Similar to that, there is a DGPS. It means differential global positioning system, which is a DGPS system. Then another very important primary source of data is a satellite data, right? So all these data sources are the form of data collection. So you use drones. The drone which has a camera mounted in it, it may be a lidar camera or it may be an optical camera, right? Which is going on capturing information. Of course, during your talk, many of the image processing talks might have also taken place. So satellite data, which are all nothing but a primary source of data collection in the form of spatial data. Similar to that, what is the non-spatial data collection primary sources? Nothing but, very commonly what we know, it is our census information, right? Where person comes to your house and ask who are all there in your house, what age they are, what do they do. So this is nothing but what census collects every 10 years. So this is nothing but the primary sources of a non-spatial data collection. Similar to that, our application to application, we collect the information, which is a primary source of non-spatial data collection. Okay. Secondary sources, where we utilize the existing or available data sources and we use for our purpose. So like suppose if there is a project which requires a certain data to be used, then we use what is available on the Google map, and prepare our map out of it. So that is something we utilize we are using a secondary source of data for preparing our information, right? Similar to that, if you ask, like government of India have, we can say there is a body called Survey of India, so which prepares topo sheets, right? Which is treated as the most authentic source of data for any area. So they give in different scales. One is to, from ranging from 1 is to 10,000, even they give it at 5,000, from 10,000 to up to 2 million. Okay, so depending on that, one can prepare the data from Survey of India maps. Of course, this depending on the scale, the information size and the content will also change. Okay, so this data which are derived from different sources will be utilized in where? Will be utilized in a GIS, which is a software tool. So now again we'll go to the definition. Geographic information system is a tool which can accept large volume of data. Data is spatial data and non-spatial data, which are derived from variety of sources. Now variety of sources, as I mentioned, primary and secondary sources. So primary sources of spatial data collections, we all discussed, like lidar or drone or satellite, DGPS, total stations, okay, and whatever other means of collecting the spatial data information are nothing but a different variety of sources. Now, since it's a GIS tool, the data which is being accepted also needs to be retrieved whenever we need to display it or whenever we need to analyze it. So the definition says, which are derived from variety of sources, retrieved, manipulated. Now here the manipulation doesn't mean we are manipulating the data. So that doesn't mean we are moving the location of a bus stop from a particular location to another location, right? It doesn't mean that way. Manipulation, it means that we arrange the data as per our need. So we categorize the data based on its requirement, based on its characteristics, and we manipulate that so that it can be easily manipulated. So we can categorize or we can manipulate the data of all the bus stops as one particular type of information. We manipulate all the trees as one particular type of information, right? So such kind of manipulation is what GIS tool allows you to do it, right? And finally, you do analyze, and one of the very important research topic which is there in today's time is display them according to the user defined specification. If you see today's time, there is one very important term which is being used and which is coined now, which is called as digital twins. Okay, and what even companies like Google and everybody are working in a big way to bring a digital twin. So what does digital twin means? It means that you represents the exact replica of what you are seeing on the ground. Okay, so that's something display according to the user defined specification, so that you feel where you are and what you are seeing is exact replica of where you are. Okay, so which is again a very very good research topic if any one of you or your students wants to take up into their research topic. So display them according to the user defined specification. So what you see in the bottom of my screen, the left side of what you are seeing is a special data, and the right side what you are seeing is a non-spatial information. So here it is shown as two different things. Nowadays there is a databases which can store a special data as well as a non-spatial data in a special data in the database itself. So they have this extension, which are special extensions are there. So Oracle has Oracle Special, SQL has SQL Special, Postgres has Postgres Special, and in fact likewise all the databases are supporting these spatial extensions. Okay, so why GIS matters? Of course, it is very very important. Almost everything happens somewhere. So geography is everywhere, right? So this program that's being held, that is also held for IIIT, and we all are at respective locations and attending this program, right? Okay, knowing where something happens is critically important in terms of what there are some of these points it is listed here, but we can count and endless they are. Somewhere where things happen is critically important with respect to its position of administrative boundaries, location of infrastructure facilities, routing the vehicle to reach to certain destinations, management of natural resources, monitoring development schemes. These are all some of the areas which is listed, but we can just think about as many topics as possible. Now, why geographical information is special? The reason being, it says that it's a multidimensional. It's multidimensional. The reason multidimensional it is told, because it can handle data which is of zero dimensional. Now, any point, okay, we said the tree, when you are representing tree, the tree is represented as a point in the geospatial system, right? So a point which is a zero dimensional entity, you can represent from point to line to polygon to to let's say an area, like the volume, right? And in fact you can represent a 3D, and even you can add the time, you can add further special parameters to represent a particular data. So that's why geospatial data is multidimensional in nature. It is voluminous, as we already have seen. You are representing, just you can count the number of trees within the city. That also will run in lakhs, right? And you are representing the full city information. You are talking about huge data set. Okay, it says requires projection to flat the surface. What it means is, now by default our Earth is represented as a globe, right? It's a three-dimensional picture. It's a sphere, and when you are representing that on the 2D plane, it requires a projection. So this geospatial data, you require projection to put the data on the two-dimensional plane. So it requires a different projection system depending on different geographical area. Okay, as you go deeper into it, you will understand the different projection system that will be required to bring the three-dimensional data into the two-dimensional plane. Okay. Unique analysis method. Each technique or each result require different analysis methods. Okay, like Google Map or we are using our Google Map right now for identifying, taking you the distance, taking you the solution from from where you are to reaching to which place. It requires some analysis method which is giving you a routing technique, right, to reach from source to destination. The same Google Map, if suppose you are utilizing for emergency response system, right? So you need to know which are all the areas where different hospitals are there during any critical scenario, any disaster scenario. So that same data can be utilized with a different analysis method, right? So unique analysis methods are required for different different data and different scenarios. Analysis require data integration, right? Obviously, data updates are expensive and time consuming. We have already seen that. And map displays require faster data retrieval. This is one of the very important thing, right? just to summarize what we just learned about geographic information system, of course, uh, like we'll see the further details, but the definition of GIS, what we just learned, it's a software tool for solving geographic solutions supported by data sets and databases, right? The spatial and the non-spatial data used by people working with GIS, geographic information and tools. It's a container of maps. What do you mean by container of maps? I give an example of manipulation of the data. So you represent trees as one particular layer, you represent bus stops as one particular set of information. So they are all nothing but different maps. So it is a container of maps, provides method for revealing pattern processes in geographic information, helps to automate time consuming tasks, and it also helps you in special decision support system. Okay, this is a sample screen of how this GIS data layer looks like. Okay, you are having a data layers of road, you are having a data layers of village boundary, this is, we are having a data layers of land use, we are having a data layers of particular locations, a soil map, and a land capabilities map. So these are some of the data layers which are listed here, and you can go on endlessly go on adding it, right? As I mentioned, you can add, if it's an urban related scenario, you can add trees, you can add bus stops, XYZ, right? So it's an organized collection of hardware. Hardware is must. Why hardware? Because obviously it's a software tool, so it will require an hardware to store uh, the software where exactly the and all the data processing will happen, the networking of data, people, and procedures, right? And finally, together comes as an organized collection of geographic information system. It started in 60s, 70s, and ESRI was one of the pioneer in development of GIS tool, right? In today's time, there are few, you can say indigenous GIS tools are there. Okay, you might have studied about this our QGIS, okay, which is a open source tool. Similar to that, we at IIT Bombay had developed indigenous GIS tool for our country, which is named as GRAM++, which stands for Geo Referenced Area Management System. Okay, that tools are there, which helps in managing the GIS data. The geographic world is infinite. You know, you can just read this sentence and it will help you. You know how GIS can help you in just representing. It says the multidimensional feature of GIS. So it says what GIS will show: the temperature at 23° north and 84° west at noon local time on 24th Jan 2004 was 18 degrees Celsius. Now you can just see there is a location aspect here, there is a temperature aspect here, there is a date aspect here, right? All this together you are representing in the one particular form, right? It often links places, time with some property of that place, right? So potential number of properties are vast. In GIS we term that are attributes. Attributes can be physical, social, economic, demographic, environmental. We just spoke about the multidimensional nature of GIS. So all these things, you can say environmental features, you can just for a particular location, what are the different type of gases which are there. Entire thing you can represent into GIS system, right? So many methods are used in GIS to create the different data models. Okay, and what are the different data types what GIS data can store? So it says geographic variations are conceptualized in by discrete special objects associated with fields. So now here we are, now what we just understood in the beginning, here we are now just going deeper in little bit deeper into that concept. Okay, so what it says, geographic variations are conceptualized by discrete special objects and associated fields. So we are now talking about a special data and a non-special data. The special objects we just spoke. What are the special objects? They are data related to the space. Now they are saying the discrete objects, and then there are associated fields. Associated fields is a non-spatial data, right? So these discrete objects are represented in the form of point, lines, and areas, right? Points, we just gave an example of representing any locational entity like a tree, like a bus stop. Line, any linear entity, a road or a river. In an area, we can say any our Sri City campus, right? So this is nothing but a discrete object and the way to represent that object. Okay, but at the same time, this discrete object representation varies as per the scale. Now this our very same Sri City campus, if you see in the on the map of, let's say, a state level map, a Sri City campus will only be a point, right? It won't be an area because the scale has changed, right? It depends from a small scale map to the large scale map. For a small scale map, the same city campus will be represented as a point. When you are coming into the large scale map, that same city map with our IIIT campus will be seen as a it will be seen as an area, right? So depending on the feature and the scale at which you are working with, your object representation also changes. But then finally, you represent primarily the GIS objects into point, line, and areas. Okay, right? Now the associated fields, it can be anything, right? It can be its village name, its population, etc. All they are nothing but its associated fields. Okay, now we'll come to the models, how the GIS data are stored in different models. Okay, so obviously you might have seen this in our earlier your your talks on GIS, but we'll just understand the concept of these models to give you more broader idea on how the GIS handles the data and how the GIS stores the data, right? So GIS mainly, where we understood the spatial data. The spatial data are primarily stored in two different formats. One is vector data and other is raster data, right? So we'll first see the raster data and then we'll see the vector data format. Okay. Now, what is raster data? Raster data is something, we all see our, with our mobile camera, we click a picture, right? So the picture that comes out, that is nothing but that's also raster data. Okay, right? So, but there is a difference between a raster that GIS stores and the raster that that a mobile camera stores, right? So, just to give you a gist, any image is a raster data, but the information that is stored in the image, in that particular image, varies from what particular data you are utilizing. Okay, so when you are talking about the GIS raster, just to give you an just to summarize, I'll not say summarize, just to explain the raster data. We can take an example of your computer screen. Okay, so what does a raster data do? How a raster model works? What does it do? Let's say we take the same example of our camera. Okay, when a camera is there, let's take a camera is trying to capture your screen. So what it does, and we'll take an hypothetical case where this particular camera is capable to capture the screen in 3 rows by 3 columns. Okay, so when they say it captures that area into 3 rows by 3 columns, so what it will do, when a camera points at your screen, it will divide this entire area into 3 rows by 3 columns. So what will happen? It will divide into 3 rows by 3 columns. It will divide the entire screen area into 9 pixels, right? So what it does, the first sentence says raster model divides the entire study area into a regular grid of cells in a specific sequence, right? So it divides the entire area into 9 pixels, right? Now this 9 pixels, each of this pixel contains certain data. Now when you are taking a photograph with our normal mobile or a normal camera, that each of the pixel will have only information related to its color, right? So color in the sense, now each since it is in 9 pixel, so the screen, the first pixel, it will see which particular color is occupying the maximum color, right? Or we can say maximum space, right? If suppose for a first pixel, which is a leftmost pixel, the maximum area occupied by the color is black. So the entire pixel, even though there is a slight pink color is there, the entire pixel will only show black in color, right? Similarly, it will come to the second pixel, it will say the maximum color that is occupied in this particular pixel is pink. So the entire color will convert into the pink color, right? So likewise, it will store all the 9 pixels with some value. So what is that value here? The value here is a color. Okay. Now, but you will say, but I am seeing different color. So what it does, that is where the concept of resolution comes into the picture, right? What it does, it when suppose since you are seeing only one pixel, says there is only one particular color is stored and you are seeing multiple colors here. Why? Because the same area is not divided into 3 rows by 3 columns. The same area is divided into thousands of rows by thousands of rows by thousands of columns. So that is why when you say my mobile camera is 48 megapixel, my mobile camera is 50 megapixel, the same area is being further subdivided into more number of rows and more number of columns, right? And each pixel stores the information about that color when you are taking a photograph. Now, same thing, let us take a case of GIS. What it does, GIS data, it's the same way, it also stores as information related in that particular pixel. What the information it stores in GIS? for GIS, it stores the information related to the feature, the geographical feature which are there on the ground. So let's take a case of bus stop and a tree and a road, right? So the entire area wherever there is a bus stop, it will give that particular pixel, like depending on if suppose road and bus stop is there, if suppose bus stop is occupying more area, that particular pixel will have a pixel value. Now this pixel, it won't store a color, it will store a value to that pixel. For example, we are taking three cases. Case number one, which is bus stop, second is tree, and third is road. So for a bus stop, let's take, we have taken a pixel value as 1, for tree pixel value is 2, and for road pixel value is 3. So wherever there is a bus stop and the pixel in which the maximum area occupied is by bus stop, it will give pixel value number 1. Similar to that, wherever there is tree, it is stored it as 2. Similarly, wherever there is a road, it will store that as a 3. Right? And after that, you can give any color you like. Right? So suppose bus stop can be represented as purple also, and road can be represented as yellow also. Okay, but then internally what system will know? The system will know that wherever there is a pixel value 3, it means that this is a road, right? So this is what it says. Now if we read this again, it says it's a space filling. Every location in the study area corresponds to the cell in the raster model. Sorry, the size of the cell defines the level of spatial details, right? More the resolution, that's why the resolution comes into picture, right? So resolution is the area that is occupied by a pixel, right? And when you are talking with reference to the actual ground area, geographical area, that's where the resolution. So you say that my image is 50 centimeter by 50 centimeter. That means one pixel is of size which is covering the ground of 50 centimeter by 50 centimeter, right? Okay, all variations within the cell is lost. So that's when I meant, what pixel occupies the largest area, or what feature occupies the largest area, that will be kept, the other area will be lost. One set of cells associated with the value is a layer, right? And the raster model that occurs at each place in the area. So it is like continuously changing value, right? So it says cell is called as a raster grid or a pixel, right? You can call it as a grid or a pixel. These coded values are in ASCII, as I said, 1, 2, 3, and can be entered manually through keyboards, right? Or it can be, it will be time consuming and tedious, it says, but nowadays we don't need to really enter it. The system automatically generates it. At the same time, we can enter it manually also. Both the places are there, but then it's all automatically done. Currently, scanners are used to create a raster data. Remote sensing directly gives the digital raster data model. So remote sensing, we are talking about the satellite data. It's already being, the satellite data stores nothing but the pixel intensity value. Already, I think that might have been covered to you. So I'm not going deeper into that. Right. This is a case of what I just explained. It shows cultivated area, right? All these pixels where the cultivated area is there, which is shown in yellow. All the red areas are settlement. All the open areas are brown. Forest area is green, and pond is shown in blue in color. It is shown as this color. However, these colors are only indicative. What is stored in the backend is nothing but its pixel value. Okay. Now, to store this data, we store different data methods to store. Some of the methods are mentioned here. In fact, nowadays they are much more advanced. But then one of the way it is mentioned here is run length encoding and value point encoding. Okay, so run length encoding, basically what it does for this area, for a particular type of pixel, from when it starts and where it ends, it just continuously stores. So like it starts from A, which stores for 0 through 10 value, right? Same way value point, up to which pixel it runs, that it stores. So it stores up to 2 and 3, which is 23. So A goes up to 23, right? Similarly, B goes from to 29. Likewise, it stores the run point and value point, so that it becomes easier to get the data back. Okay. Similarly, there is other way to represent it, chord tree. So you define the data in different chords, right? So that it becomes easier how we define and subdivide into binary tree, and finally come to the result. So it's the same way you store the data. You store the data, and then you'll be able to retrieve the data up to the last finest level. Okay, so this tree will help you, in schematic representation of any special feature which is there on the ground, and then retrieve it back whenever we want to utilize that. Okay. So this completes our raster data model. So now let us understand the vector data model. So as we have seen, for raster, it's all about pixel. Now for vector, it's all about points and vertices, right? As we all might have studied in our school days, any vector means it's a magnitude and direction. So it's the same concept we are utilizing here for storing a geospatial data in the vector format. We are storing its magnitude and the direction with some reference, right? So what is the directions that part we are storing? The direction, the part that we are storing is we are taking the direction for in the form of latitude and longitude. Okay, so latitude and longitude, when we are storing, it is with reference to the imaginary latitude and longitude lines which are drawn on the earth's surface, right? So that is when we say a particular location is 22 degrees and 72 degrees north and 72 degrees east, it means that for a center of 0 0 which is located at this point, this particular point is 22 degrees north and 72 degrees east. So this is somewhere, we have utilized a concept of the direction here. Okay, and then when we add a magnitude part to that, the value part to that, we can represent that particular value. Okay, so like that, in vector data model, we store in the form of vertices. So that's why it is, if you read this, the first line says functional primitive unit is a point. So any location, any details, you always store as a point, right? So from point, when you connect a point, it becomes a line, right? Or it is also called as an arc, right? So when you connect a line, so it is functional primitive unit is a point. From point, when you connect the points with the straight lines, it becomes an arc, right? So this area defined as a set of lines or arcs, right? And then when you go on connecting the dots, go on connecting the points, and finally when a start point and the end points are the same, you form it as nothing but an area, right? That's why it says the areas are defined by the set of lines or arcs. Okay, so functional primitive. So when suppose you say I want to digitize a road, so what you are going to do? You are going to go on digitize point, and finally that points are getting connected in the form of line. So that means a linear feature of road got connected in the form of line, right? Similarly, arcs are created, right? Okay, like a bus stop, it will always be represented as a point. A tree, which will always be represented as a point. Okay, right? So every piece of boundary line is a common boundary line between two areas. Now, this particular sentence refers to building a topology of a vector data. So, what is topology? Topology is nothing but a spatial relationship between the feature, right? So, suppose you are drawing a area. Take an example of Maharashtra and Gujarat. Okay, so Maharashtra and Gujarat share a common border, right? So this particular common border, when you are representing in the GIS model, this when a spatial relationship is established, this common border line will be stored only once. So when this particular line, this common border between Maharashtra and Gujarat, will know that this is the line which represents the border between the upside to me is Gujarat and downside to me is a Maharashtra. So this common boundary understands that, right? So common boundary line between the two junction node is called as an edge, chain, and an arc. Arc is fundamental in vector GIS, and each arc have an attribute which identifies the polygon on either side, right? This is what I meant by spatial relationship. Okay, this is a simple representation of point, line, and polygon. I'm not going deeper into that because you might have already studied that in your UGIS session, right? Typical storage of data. Now it says polygon storage. Obviously, yes, polygon storage it is mentioned here, but the topological structure also works for a linear storage. So it is a line data. So a classic case of example is nothing but it's our road network. Okay, a road network cannot be built without establishing a topology. So now we'll just understand what is non-topology and what is topology. This is a polygon storage. So non-topology, every polygon is stored in the sequence of coordinates. So as I mentioned, if you are talking about Maharashtra, so Maharashtra will be stored as the latitude, longitude coordinates. So sequence of coordinates, this is how the Maharashtra has stored. And same way Gujarat. So this is how the Gujarat has stored. And the common boundary line is also stored twice. So common boundary line between the two nearby areas are coded twice, one for each polygon. So one for Maharashtra, one for Gujarat. So we are repeating the storage. When it's a topological structure, what happens? Every arc is stored as a sequence of coordinates. So that sentence itself says it divides the area into arcs, right? And these arcs are built by connecting. These areas are built by connecting the arc, linking the arcs. Okay, and this arc, which is a common line between the two polygons, are stored only once. Okay, so because why it is once? Because so that it understands the spatial relationship between the polygon which is of Gujarat and the polygon which is of Maharashtra. Okay, so now this particular thing, this is where the utilization of topological structure is very important. Similarly, when you're talking about a road network, how Google efficiently finds out if suppose you want to go from point A to point B, why it's very efficiently is able to find out this is the route you should take from point A to point B. Why it is able to find out? The very own reason is it builds a topology of entire road network, right? And it stores that topology. How it stores that topology? It understands that arc A is connected to arc B, and this arc B is connected to arc C, and this is the junction where arc A and arc B is getting connected. So now, according to that, you give the distances, right? So according to that, it is able to find you the entire route from point A to point B. Okay, right? So this is how the polygon, the topological structure is stored. Okay, right? So once the data is created, we also need to store a database. So once a vector database is created, you need to clean, edit, build topology has been carried out. So building topology calculates and encodes relationship between the point lines and areas, right? So that it does. Okay, this is an example, right? So if suppose it's a closed loop of point, this is how you normally represent a data. So 10 is it's x and y, right? For this particular point, for 23 it's a linear, so it is series of x and y's. For polygons, this is series of x and y's where start and end are one and the same, right? Normally when you digitize, they are all nothing but you always get a topology. You are likely to get, I'll not say always, you are likely to get certain errors, or we can say the dangles in data creation. So this is nothing but they are all called as overshoots, undershoots, or even they are dangling segments. So they are hanging segments, or even they are called as sliver polygons. So these are typical terminology of dangles which you get it in the while digitization. So some places you may not, your line is not touching the boundary, or the case A where some places where your line is going above the boundary, or case C where there is case C like this where there is a sliver polygon. Okay, so such cases you have a automated tool to solve this problem, which will automatically, the GIS system has a tool which will automatically connect this point to this particular line, or which will remove this additional line from this particular line, or it will remove the slivers and solve the data. Okay, so this is something which is possible. If not, you can also solve it manually. Okay, so this is what it says. Topology, it's a simple features, connectivity, adjacency, sharing, all these things, this data can be identified. And topology will be utilized for data validation and spatial analysis. It says network tracing, right? Network tracing is all about utilizing it for routing problem. Okay, so this is topology building. It's just a case study has been given based on what we just explained, right? So raster versus vector, if you ask volumes of data, raster is more voluminous compared to vector, right? But in nowadays people are using more of a vector data in terms of solving, because the computation capacity of our computer systems have become so capable that we are able to handle huge size of vector data. So most of our applications are vector driven uh, rather than a raster driven. But at the same time, there are many applications which require only a raster type of data model to be utilized. Okay, so that's why it says some applications are better suited for raster model, some other applications are better suited for vector. So you take a case of air pollution, you take a case of watershed modeling. So they're all application which 100% requires only and only a raster data model. However, representation wise, people favor the vector, where administrative boundaries are there and all these things are there. Right? Elevation related entire data you better represent as a raster data. Yeah. So this is another type of model which is there, which is normally used for for the area which is with for identifying that network, we can say the elevation network, right? So what you are seeing is nothing but a triangulated irregular network where the elevation points are connected in the form of by forming a triangle, so that the triangles are as equiangular as possible, and it also gives you interpolated values of the elevation data. Okay. RDBMS, as I said, is a non-spatial attribute information where the data is stored. Okay. Data collection, I explained in the beginning. There's a primary way. So we use the word derived from variety of sources, right? So primary and secondary. So vector data, the primary sources are GPS, survey measurements, right? Okay. Raster data, it is detailed remote sensing images, aerial photographs. Okay. Secondary data sets are scanned maps. So somebody's maps are there, we are using it. Somebody's prepared the DEM, we are using it. Somebody's topographical survey we are utilizing, or atlases we are utilizing. Okay, so that is a secondary source of data sets. What does a GIS do? It gives an answers to so many of this. Some of these are written here, and we can very well easily connect to that. What is at a given location? Where does it occur? What is nearby? What trends are occurring? What happens if, right? So what happens if is very crucial thing in terms of modeling. Okay, with special analysis we turn raw data into useful information. We can understand the patterns and trends and anomalies that might otherwise be missed. We sometimes we feel that yeah, ऐसे ही होगा, right? It will be like that only. But when we really see with the geospatial techniques, we'll really understand how it is happening and where it is happening. One of the classic cases when somebody has utilized gram plus plus was one of the case study during in 2005 or something, where there was a bird flu in Maharashtra. Okay, he utilized gram plus plus for identifying the origins of bird flu, from where it is entering in from the epicenter, right? And if it has to be, certain roads has to be cordoned off, which are all the roads that require to be cordoned off. Okay, so with that he really understood how this threat can be minimized. Okay, so provide check on human intuition. Okay, these are all some of the types of spatial analysis techniques, and there are many are there. In fact, you can go on adding, but some of them which are listed here are querying and reasoning, measurement, overlay operation, neighborhood operations, connectivity operations. Okay, so these are all one of the simple map display of soil, where it is displaying. This is a contour display. This is perspective view. Then this is what you are seeing is a solar radiation map. It is generated by a tabular query. So you are representing a spatial result by utilizing a non-spatial result. So in the backend, you run a non-spatial query where you try to represent, show the area where post offices, PCOs, and bus stations are there. So these are in the green. What we are saying is these are all the areas where all these three facilities are there. At the same time, the one in purple color, it shows that this particular regions, they do not have any facility. So for an administrator to decide why these regions have no facility, he can take actions accordingly and set up a new facilities if we require. Okay, we do many of the overlay analysis. So when you overlay analysis, it's a very difficult and complex situation in GIS, but the GIS systems very efficiently handles that. You can just take the simple case of two polygons A and B. So when you just overlay these two polygons A and B, this overlay forms 9 different polygon composition of only A, only B, or A and B both. Okay, so but then GIS system can very efficiently handle this. Okay, so then one of the example it is shown here, the neighborhood operations, right? A classic case in defense. Okay, identifying a slope of an area, right? So even for a watershed, like if suppose you want to design a irrigation system or a check dam, okay, you first need to know how the water will flow and from where it will start and which place it will get accumulated, right? So you need to understand the slope, right? So these are all the examples of neighborhood. So it will consider the neighborhood pixel, and it will calculate the slope with respect to the center pixel. Okay, and which area has a maximum slope, it will assign to that particular pixel that slope, and according to that one can estimate the slope of an area, and that slope can be utilized for identifying a normal watershed, or even this slope can be utilized for any utility related system aspect. It will give you how the direction of the slope it is, So that you will be able to identify. So which side the water is going to flow. Routing doesn't need to tell much. With Google Map, we all are aware about allocation problems. So, like DMarts, or say even we can take an example of in case of disasters. So the red dots are the places where there is some relief is required. Okay, and the center dots of green, red, and blue are the places where the relief centers are available. Right? Using GIS analysis, the allocation problem solving capability, the system will automatically tell you which are all the centers will cater to which are all the demand nodes. So it's like demand supply problem solving capability. Right? So DMart can set up their warehouse, and which warehouse will cater to which are all DMart spaces. Right? So buffering, we all know, so encroachment studies, and we can say we need to cordon off certain areas. So you use nothing but a buffering problem. So you have point, line, and polygon buffers. At the same time, you have internal buffer, external buffer, visibility analysis. So in today's time, where big buildings are in very common thing. So people would like to see, suppose my building goes say more than 100 meters, what are the additional area I get to see, and you can charge premium on that, right? And if you talk with the defense scenario, if I build a watchtower, how much more area will be visible to me, right? So what you see on the right hand side is nothing but a point from where you are visualizing, and the green areas are the area that is visible to that from that particular point. Let's take a scenario where a particular height of the watchtower is to be constructed. Okay, so this is again like we can say disaster scenario, where if the river is getting flooded, what are the area that is going to come under the submergence? We'll get to know. Okay, visualization, standard visualization methods are there. As I said, it's one of the very big area in which people are putting a lot of efforts, and lot of research is going on in terms of how efficiently and how quickly we can prepare the visualization. This is a standard visualization method wherein you are preparing the map with the standard map parameters. So what are the standard map parameters? It should have a title, it should have a subtitle, north arrow, then it should have a legend, it should have a scale. Another thing which is missing here is nothing but a lat long grid. So that things are minimum required for a map to be called as a map, right? Standard zoom in zoom out feature, which is a part of a GIS system. 3D visualization, obviously nowadays it's a we can say people have looked for it. Multiple map viewing, you are from a higher scale map to the lower, you go dig deeper into that, right? So you go from one level of data to the last level of data possible. Okay, obviously when you are working with GIS data, you also need to take into consideration different uncertainty, right, which is a measurement error. So suppose you are utilizing a total station data, and you are utilizing a drone data, obviously there will be a measurement wise, there will be a variation for the same location, right? At the same time, there will be an error which can be an observer also can create an error, or instrument can create an error, right? So that errors need to be considered. Okay, and then based on that, the data has to be prepared, so which will tell you the quality of the GIS data that is prepared. Okay, and accordingly the analysis should be it should be taken out. Application wise, these are very few applications which are listed here. Okay, rise from agriculture and defense, government agencies. E-governance is one of the big area now. I don't know how many of you are knowing about Swamitva mission of Government of India, which talks about we can say drone based survey of all the land parcels of our rural areas. Okay, and then giving them a land card. Okay, so that the dispute of land management can be resolved. So many applications are there. These are very few applications which I have just listed here, but there are so many applications which are there. So 1 0 is missing here. It is about 200 billion industry, right? In terms of professional, the functionality will be the highest. In terms of internet, the functionality will be lesser, but at the same time, number of users like Google Map will be huge. Okay, right? So GIS software, of course, this is what the same thing about previous speaker had spoken about. Clear objective, project orientation, focus time scale, risk management, and effective communication will solve the problem, right? So finally, this is the last to talk about. Understanding GIS requires considerable science, systems, and studies. GIS provides a framework to manage the world. The real value of GIS is its problem-solving capability, right? future of GIS is very, very bright. Okay, in India's scenario, if you talk, it's really a era, where GIS has been taken very, very seriously now. So thank you. Just thank you very much.
Thank you very much, sir. It's actually really a privilege to have you here with us. Really an intuitive lecture, and I hope all of us enjoyed it. Participants, any questions, please? We can take up one or two questions. If you have any questions, either you can ask directly or you can put in chat box as well.
Professor Arun, you can always share my contact details. Anytime they need any help or assistance, we are happy
Sir,
to help.
definitely. Sure, sir. Yeah, so participants, please
Thank you.
feel free to contact us if you need contact details of sir.
I'll just
And yeah, thank you very much, sir, once again, and thank you all the participants. Thank you,
in fact,
sir, actually on behalf of IIITS 360 as well as the organizing committee. I sincerely thank you, and it's always a pleasure hearing you. I mean, thanks again.
thank you. Thanks a lot.
Yeah, thank you all. So we'll close the session. So tomorrow's links I have emailed you. Kindly join. Participation is quite low. We will be monitoring the attendance strictly. Kindly join all the sessions. Thanks again, and wishing you a good year once again. Thank you.